in here with topic 14 still, and on topic 14 we're going to be talking about systematic sampling. This is the second of the three different types of sampling systems that we're going to use. That was Survivor with Eye of the Tiger, obviously, for all you people out there. The key concepts, again, was not effective here in terms of popping up, I don't believe, so we just kind of ruffled through that, skip over top of that for now since it's not going to bring it up. We'll go ahead and go to part one. And again, a calculator may be helpful here. So the first thing we have to understand is with systematic sampling is a type of sampling system whereby you're going to set up an organized list, all right? And when you do this, we have to first of all in this choose out of the three pieces here which one represents a systematic sample, all right? Or which two or which three, maybe all three of them. So letter A is classic. You make a list of students in your class and you choose every seventh name starting from the first name. This is a classic systematic sampling example. Look at B. You have students in your class count off by fours. You choose the students who are counted three. Think phys ed class with Smucker. Boom. That's right up your alley in regards to that too is a great example of systematic sampling. And then C should look very familiar to you because you're making a list and you're going to choose the first 10 kids. And so that obviously represents something we saw in the previous section, and that's an example of convenience sampling. So my answers there should be A and B are my representations of systematic sampling. All right, moving on to the next one, movie theater. We're going to survey customers who to make sure they're maintaining a customer-friendly environment, which description indicates a systematic sampling taking place. Look at number one here. You ask every movie goer that walks into the theater, is that systematic? No, that's systematic. That's basically going to be impossible. If I look at number two, choose one customer that comes into the theater. Again, that's not a very effective way of systematic sampling because obviously that means that sample is just not going to be enough evidence. There's not enough people in the sample in order to make a good sample. And then the third one, starting with the first moviegoer, you're going to choose every fifth moviegoer that comes into the theater. That should look a lot like one of the examples that we saw from the previous slide. And then the fourth one, select the first 20 customers that walk into the theater. Once again, that one should look familiar to you, and the reason it should look familiar to you is because it is convenience sampling. All right, let's move on then to slide 3. And on slide 3, it does a really good job of comparing the two. How are convenience sampling and systematic the same, and how are they different? And as you can see, do they both produce a sample? Yes, they both produce a sample, albeit convenience is not a very accurate sample, I guess I would say. So the sampling system we're going to see here in section 4 is a lot better situation than the convenience sample. Does it produce a representative sample? Convenience, no. Systematic, it does if you don't have a pattern. Again, think phys ed class. If some of you guys know that Smucker's going to count off by 4, and so you line yourself up so that you and your buddy are on the same team, being 4 apart from each other, then obviously it's not going to be a very effective systematic tool that's going to give you a good mix. Requiring knowledge of the population size. Convenience, no. Doesn't matter how many people are in the situation. Systematic, yeah, you got to know how many you're getting, how many total there are, and how many samples there are. Require picking from numbers at random. On convenience, it is a no, and on systematic, the first number that you choose is basically a random requirement. And then the one thing about convenience is it doesn't take much time, and systematic obviously does take some time as you run through the population. All right? Okay, we'll take a break now for our commercial. Okay, picking it up right here now on part 2, taking a look at what we got. We have 72 science books. Okay, 72 science books. You're going to decide to sample 9 books in the section. So first thing that you want to do is you want to determine what your starting number is going to be. And so if I take 72, which is this number right here, and I want 9 samples, okay, it's going to tell me the interval. All right, so the interval is 1 through this number right here. A lot of times they refer to this as n. So 1 through n which is in this case 1 through 8 would be, so 1 through 8, you must start with books 1 or 2 or 3 or 4. So you're randomly going to select one of those numbers, all right? You could use a dice to do that. You could use anything, a random number generator to do that. You could just pick a number out of thin air. Let's say that you choose the number 3 is going to be your starting point, okay? If you choose the number 3 as your starting point, then this end number, this becomes really important because this tells you what the interval is, all right? Therefore, if I look at 3 and start with 3, the interval is going to be 8, so the next number is 3 plus 8, which is going to be what? 11. I would add 8 to 11, so the next number is going to be 17. Add 8 to 17. My next number then is going to be 25, all right? So on and so forth. Add 8, 33. Add 8, 41. Add 8, 49. Add 8, 57. Add 8, let's go to 65. Add 8, I'm at 73. And this is when you have to realize when you have to stop. You have to stop when you pass the threshold of the total number of the population in essence. You have 72 books, therefore you can't pick book 73. So at this point, you need to stop and realize I should have my 9 samples right now. Okay, so I would count them up and say I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my 9 samples. Once again, you might have people who don't start with number 3. I mean, Mr. Clark could have started with number 7. Mrs. Rockwood could have started with number 1. Mayhew has 2 kids. Maybe he starts with a number 2. Mrs. Bourne could have started with number 5. All right. It doesn't matter where you start as long as you start between 1 and n. All right. And then that n becomes your interval. And in this case, that is 8. We'll see that on the next example as well. We're going to take a commercial break here and give you your code word if you're paying attention to this. And your code word for today is, boom, Pete Puma. Pete Puma. Back to our show. So I'm going to go back to the show, and we're going to roll this to my next slide. And my next slide, you have students in your grade. You have a dream. Who has a dream about flying? And you're going to basically say we have a population of 340 students in our grade level. How many would you have to have in order to get a systematic sample of 20 students? So these are the 2 pieces of the puzzle that we want. I'm going to go ahead and bring up the answer here just to show you so I can discuss what's going to happen if I choose a different number, all right? So as you can see, what they're saying is our first step in this process is going to be, we're going to assign each student a number from 1 to 340. And then I basically jumped it to step 2 of my prior example. We know that the population is 340, and we know we want a sample size of 20. So therefore, we're going to take the population, in order to determine what our n is, we're going to take the population and we're going to divide it by the sample size. So 340 divided by 20 is going to yield 17. Now, what is this going to do for us? This tells me I have to start somewhere between 1 and 17. All right, they're choosing the number 6, which is fine. I'll show you here in a little bit. I'm going to choose a different number in a little bit, and we'll see where that goes with everything. So they're choosing the number 6, and I'll slide this back down, and then you can see that because they're choosing the number 6, we're then going to take the 6 as our starting point, and we are going to add 17 each time to get our very next number in the sample. All right, and then those students are going to be the kids who represent that particular sample. And when do we stop? Once we cross 340, if I would take 329 and I would add 17 to it, I'm going to be at 346. And so 346 would be past the number 340 for the population I have, and so therefore we couldn't count it. All right, so that should produce my 20 samples that I want. Now again, you could start as easy as you want. If you wanted to start with the number 1, you could start with the number 1 and get 20 samples that way. Now I'm not going to run them all the way out, but I'll take it out a little way. So I'm going to start with 1, I'm going to add 17, I'm I'm going to add 17. I'm going to add 17. I'm going to add 17. I'm going to add 17, so on and so forth, until I get to the threshold of 340. Once I cross over that threshold, then I have to X out that number, and now I should have 20 numbers in that pot, all right? 20 samples, if you will. Questions there? All right, let's move ahead then to my next piece of the puzzle, part 3. When might a systematic sample not be a representative sample? We talked about this in brief a little while ago. Obviously, if there is some sort of pattern to the list, it's not going to produce a systematic sample. Okay. All right, part 3 now. So let's take a look at part 3. We have 2 comments here. This is tough one to understand. So again, just like we always think, part 3 is the most difficult stuff. You want to estimate the number of purple lights in a light display. You decide to take a systematic sample using an interval of 5 lights, starting from the second light. All right, so here we go. We decided they want to use an interval of 5, starting from the number 2. All right, so we're starting at 2. And we're going an interval of 5. So I'm going to add 5, which is going to be 7. I'm going to add 5, which is going to be 12, so on and so forth. All right, we're going to follow that pattern, if you will, that process. So here we go. Watch what happens here. So suppose there are 300 lights in the display. Using this systematic sample, how many purple ones do you think you're going to get in the display? And how accurate is your estimation? So here we go. We're going to start at number 2. Here's my second one. And now I'm going to go every 5th one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And so you can see what's happening here. Based upon what we're doing, we're getting yellow every time. And so based upon just that sampling, you're going to say, hey, how many of the bulbs are going to be purple? Well, there's not going to be any purple because every light that we've circled so far has been yellow. And why is this a problem? Well, obviously, goes back to what we got to pay attention to when we get a systematic sample. There is a pattern here, and this pattern is every 5th light is the same color. All right? So that's going to create a very poor sample in this particular situation. Suppose there are 300 bulbs. We already talked about that. How many purple bulbs do you estimate? We're not going to get any. So we move on to our next problem. Suppose you want to estimate the number of purple bulbs in the light display, and you decide to take a systematic sample using an interval of 6. Okay? So a couple things here. You want to estimate the number of purple lights in the display. You're going to take a systematic sample. You're going to use an interval of 6 lights, starting from the second one again. Okay? Suppose there are 300 bulbs in the display. Using your sample, how many purple light bulbs do you estimate are going to be in the display? How accurate are you now? All right? So if I take a look real quick, the one thing I want to pay attention to is I don't have a long strand of lights. So I think what I'm going to do is I'm going to go ahead, I'm going to put down the colors of the lights real quick that you see here. So I see red, yellow, green, blue, purple. Red, yellow, green, blue, purple. It's going to follow that pattern the whole time. Okay, it's going to follow that pattern. Red, yellow, green, blue, purple. Red, yellow, green, blue, purple. I'll go one more. Red, yellow, green, blue, purple. All right, so the lights themselves have a pattern to them. Okay, now it states that we want to start with the second light, and so that means I'm going to start with this dude right here, the yellow guy. All right, and then we're going to go ahead and it says we're going to go interval of 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay. Now, the next one would have been a red. So what we want to do is we want to pay attention to what's going on here. All right. It looks as if I chose, what? We're trying to get the 300 light bulbs. So you're thinking right now, hey, 300 light bulbs, that would represent my total. I'm looking for a proportion here, really. And it looks as if, based upon what is going to happen here, in the ones that I have chosen, I have what? 1 out of every 5 bulbs is going to be a different color. I mean, if you take a look at what's going on here, on my first draw I got yellow, on my second draw I got green, on my third draw I have blue, on my fourth draw I have purple, and on my fifth draw I had red. So the chances of me on my 5 draws of getting what? Purple, I think is the color I'm looking for, yeah, is 1 out of 5. Okay? So I'm going to predict that X is going to be, if I cross product this or whatever, I'm going to predict that 60 of the bulbs are going to be purple. Okay? Now let's see what they say, and this should show you exactly what I talked about. Since the pattern of the display repeats with intervals of 5, each color of light appears the same number of times in the display. The pattern repeats. Estimate should be fairly accurate. If I do make it a 1 here, so systematic, we got 10 reds, 10 yellows, 10 greens, 10 blues, and 10 purples. So they're going 10 over 50 or 1 over 5, which is what I did. Okay. Again, if you went 5, 10, 15, 20, 25, we could do it that way. But either way you look at it, we're going to want to set up a proportion, and this is where you're going to have some difficulty, I think, when it comes to your homework. So this will be a good place to go back and take a look at this. You could have done the same exact thing, except pick every, what? As long as you didn't pick a multiple of 5, you'd be okay. So you could have picked every second light. You could have picked every third light. You could have picked every 4th light. The only one you really couldn't pick, you didn't want to pick every 5th. That would be a bad idea because it's a pattern of 5. You wouldn't want to pick every 10th because, again, it's a multiple of 5. All right? Okay. That'll do it for today. Have a great day and good luck on that homework. Thanks.